Hello everyone, I am Akhilesh Kumar Srivastava from ABS Engineering College, Ghaziabad. In the series of the operating system lectures, we will be discussing about the shortest remaining time first algorithm today. Shortest remaining time first algorithm, as the name suggests, that we will be selecting the process on the basis of the shortest burst time. But this is the preemptive scheduling. We already have studied about the SGF scheduling algorithm, which was the shortest job first algorithm. That was the non-preemptive version. Now we will be discussing the preemptive version of the same. The preemptive version of this algorithm means that when a process is arriving, it will be allocated the CPU according to the shortest burst time. But in the future, if any other process shorter than the currently running process comes, then I will preempt that process and will allocate the CPU to the next coming shorter process. So, this is the preemptive version of the shortest job first algorithm. So, the outline of the lecture would be that we will first discuss the CPU scheduling basics, then we will discuss about the shortest remaining time first algorithm, and then the merits and the demerits of the shortest remaining time first algorithm. Now, we already discussed about these things, but just have a quick reminder of all these parameters. The arrival time means at what time a process is arriving in the ready queue. Ready queue means a queue is maintained of all the processes which want to execute the CPU. So, at what time with respect to the CPU cycle a process is entering in the ready queue. Burst time means how much time a process requires for the completion or how much time a process wants to execute at the CPU. In other words, you can say that how many CPU cycles are required for a process to complete. Now, the turnaround time means how much time a process has spent in the system. It means a process is submitted at some point of time and the process terminates or finishes. So, what is the difference between the two times? So, that is the turnaround time. How much time a process has spent in this system. Waiting time means some time was allocated for the process to do the CPU execution. Rest of the time it was waiting. It means rest of the time it was waiting for the execution at the CPU or it was doing some IO operations. So, the time which it has elapsed for CPU execution, that is the burst time, and the time which it has wasted is the waiting time. How do we find the waiting time? We subtract the turnaround time from the burst time and the difference actually is the waiting time. The response time means what is the first time the process has got the CPU. We have seen the round robin scheduling mechanism in which a process was given the CPU for a short duration, then the CPU was taken back. We were allocating the CPU to some other process. So, when one cycle completes, the process is allocated the CPU again. So, meaning that a process is not finishing the moment it has got submitted. It may get the CPU several times, but what is the first time the CPU was allocated to the process? So, what is the time at which the first time CPU is allocated to the process is the response time. So, now let us talk about the Srtf scheduling algorithm. As I already told you that the CPU is allocated to the process for some amount of time and then it is taken back. It means when the CPU is allocated to the process and the shorter job arrives, then we are taking the CPU back from the process and we are allocating the CPU to the another process which is having the shorter burst time than the previous one. So, it is not the time quantum, but it is for some time up to which no short process is arriving. The moment the short process arrives, we will preempt this process. Okay? So, CPU is taken back from the process when the new process arrives of shorter duration. Fine. Now, let us solve the numerical for this. This is the situation wherein there are 5 processes, and these 5 processes are arriving at time 1, 2, 3, 4, 5 respectively. This is the Gantt chart. At 0 time in the Gantt chart, I cannot allocate any process, because there is no process arrived at 0 time. So, from time number 0 to time number 1, the Gantt chart remains empty. At time 1, process number 1 is available. So, let us give the process number 1 the CPU for a small duration of, let us say, 1 second or 1 unit, and at 2 time you see which process is shorter, meaning that आप देखिए कि 2 टाइम पे क्या कोई और प्रोसेस है जो कि शॉर्ट है देन द करंटली रनिंग प्रोसेस. सो द P1 प्रोसेस इज रन फॉर 1 टाइम, इसका रिमेनिंग बर्स्ट टाइम 6 है. 6 और 5 2 टाइम पे केवल P2 प्रोसेस अवेलेबल है, तो 6 और 5 में 5 छोटा है, इसलिए P1 प्रोसेस को प्रीएम्प्ट करके हम P2 को CPU दे देंगे. P2 जो है वो 1 यूनिट ऑफ टाइम तक रन करेगा, और उसके बाद 3 टाइम पे P3 प्रोसेस भी आ गया. Now at 3 times, since P3 process is available, it has a burst time 4. Out of 1, 4 and 6 means P1, P2 and P3 is burst time. 1 is the smallest one, so P3 process को हम CPU allocate करेंगे और ये complete कर जाएगा. At 4 time, another process P4 has arrived. So at 4 time, Gantt chart में देखिए कि 4 है current time. 4 टाइम पे मेरे पास 3 प्रोसेस है जिनको मुझे CPU देना है, P4, P2 एंड P1, लेकिन शॉर्टेस्ट वन जो है वो P4 है, इसलिए हम P4 को CPU एलोकेट करेंगे. नाउ P4 1 यूनिट ऑफ टाइम तक रन करेगा और 5 टाइम पे P5 प्रोसेस भी अराइव हो गया. वी हैव टू मेक द कंपैरिजन एट 5 टाइम. So we have processes with the burst time 8, 1, 4 and 6. Out of this, the smallest one is 1, so P4 continues its execution and it will run up to completion. After this, we have 3 processes, P1 with 6 burst time, P2 with 4 burst time and P5 with 8 burst time. Out of this, P2 is the smallest one, so the CPU is allocated to this process till its completion. Since there is no conflict afterwards, so we do not need to preempt this process in between. इसलिए हम P2 process को completion तक run करते हैं. ये complete हो जाएगा. Then we have 2 processes P1 and P5. Let's allocate the CPU to process number P1. It runs up to completion. It means up to 16 time. And then we can pick the only left process, that is P5, and allocate the CPU to this, and it finishes at 24 time. So this is the Gantt chart for the given numerical, and we have to find out the completion time. How do we find the completion time? Let's move from the let's move in the Gantt chart from right to left, and let's find out at what time the process is seen for the last time. So P5 is seen at 24 time, P1 is seen last time at 16, P2 is found last time at 10, P4 is seen last time at 6, P3 was seen last time at 4. Let's compute the turnaround time. The turnaround time is the time a process has spent in the system. So that will be completion time minus the arrival time. So 16 minus 1, 15 is the turnaround time for P1 process. Similarly, for P2 process, 10 minus 2, 8 is the turnaround time. For P3 process, it is 4 minus 3, that is 1. For P4 process, 6 minus 4, that is 2. And for P5 process, 24 minus 5, this is 19. Now let us compute the waiting time. So the waiting time will be turnaround time minus burst time. How much time is wasted? Is the wastage of the time. So, the only time which is relevant time is burst time, rest of the time has got wasted. So, for waiting time for the process number 1 will be 15 minus 7, that is 8. P2 process के लिए 8 minus 5 3, P3 process के लिए 1 minus 1 0, P4 process के लिए 2 minus 2 0 और P5 process के लिए 19 minus 8, that is 11. Now, let us compute the response times. So, the response time will be found by looking at the Gantt chart and what is the first time you see a process in the Gantt chart. So, first time you see the process number 1 at 1 time, process number 2 at 2 time, process number 3 at 3 time, process number 4 at 4 time, and P5 is seen at 16 time. Since these are the relative times, so let us subtract the arrival time from these. So, 1 minus 1 0 is the response time for P1 process, 2 minus 2 the response time for P2 process is 0, 3 minus 3 response time for P3 process is 0, 4 minus 4 response time for P4 process is 0, and 16 minus 5 11 is the response time for P5 process. So, these are the parameters that we have calculated in the examinations or in the GATE examination or in any university examination. We have to find out the average waiting time, average turnaround time and average response time. You can find out these parameters by summing up all the response times and divided with the number of the processes. For example, in this case the average response time will be 11 by 5 because 11 is the sum of all the responses, all the response times, and 5 is the total number of the processes. Now, let us solve another problem for the Srtf. Here we have only 3 processes. Let us make a Gantt chart. At time number 0, only one process is appearing, that is the P1. So, let us allocate the CPU to P1. At time number 2, another process comes which is P2. So, we have run this process P1 for 2 times. So, the remaining burst time of P1 process will be 8. At 2 time, process number P2 has also arrived. So, let us allocate the CPU to P2 process. No, sorry, it will not be allocated to the P2 because we have less burst time for P1. So, P1 will continue. So, let us continue this P1 up to 4. So, up to 4 means 2 unit of time, means at 18 time, at 4 time it will be 18 its remaining burst time, sorry, it will be 6. We have not allocated this to P2. Now, at 4 burst time, P3 process has also arrived. So, out of P1, P2 and P3, P1 is the smallest one. So, let us continue this P1 only. So, there is no conflict, let us run this to the completion. So, 6 is the remaining burst time. So, it runs up to 10 time and it finishes. After this, the smallest one is P2, let us pick it up and run it to the completion. 10 to 30 because its burst time is 20. Now, let us take the process number P3 and run it up to the completion, means it will finish at 60. Let us compute the parameters, required parameters one by one. The P3 process finishes at 60, P2 process finishes at 30 and P1 process finishes at 10, looking at the Gantt chart from right to left. The turnaround time is completion time minus arrival time. So, 10 minus 0 is 10, 30 minus 2 is 28, 60 minus 4 is 56. Now, the waiting time is the turnaround time minus the burst time. How much time is wasted? So, 10 minus 10, 0 time is wasted for P1 process, 28 minus 20 it is 8, 56 minus 30 that is 26 for P3 process. Let us look at the response time, what is the first time the CPU is allocated to any process. So, go in the Gantt chart from left to right. So for P1 process it is 0, for P2 process it is 10, and for P3 process it is 30. Since this is the relative time, we will have to subtract the arrival times from this. So 0 minus 0, 10 minus 2, 8, and 30 minus 4 is 26. In case you find out the average waiting time, average turnaround time, and average response time, these parameters will be, average waiting time means sum all the waiting times. So 0 plus 8 plus 26, that is 34. So 34 divided by 3, because the total number of processes are 3. Average turnaround time means 10 plus 28 plus 56. So this will be 94. So 94 divided by 3 is the average turnaround time, and the average response time will be 0 plus 8 plus 26, that is the 34 by 3. Here you can see that incidentally in this question the response times and the waiting times have come same. Let us solve another problem. In this problem, P1, P2 and P3 three processes are given, and the burst times are given as 9, 4 and 9. So in the Gantt chart I can pick the process number P1 at 0 time, but at one time another process is arriving. So let us preempt this process P1 at one time and see which process has come. चूँकि P1 प्रोसेस ने 1 यूनिट ऑफ टाइम एग्जीक्यूशन कर लिया है, इसलिए इसका जो रिमेनिंग बर्स्ट टाइम होगा वो 8 होगा. P2 प्रोसेस 1 टाइम पे अराइव हो चुका है जिसका बर्स्ट टाइम 4 है. आउट ऑफ 4 and 8, 4 is the smaller one. So we will check, or we will pick the P2 process for execution, and this P2 process will run only for 1 unit of time, after which I will preempt this, and we will see if any other process has come. Yes, P3 process has come at 2 time. If we compare these 3 processes and their burst times, so burst times are 8, 3 and 9. इसमें से सबसे छोटा जो burst time है वो P2 का ही है. So we will continue this P2. Since there is no conflict, so P2 process will run till the completion. So we are running this P2 process up to 5 for its completion. There is no conflict. When the P2 completes, there are 2 processes, P1 and P3. The smallest one out of these 2 is P1. So this will be picked for the execution, and this will run up to the completion. So 5 plus 8, 13. So the P1 process finishes at 13, and then we have only process remaining, that is P3. We can finish this up at 22, because 9 is the burst time for P3 process. Now the completion time can be found by looking at the Gantt chart from right to left. Completion time for P3 process is 22, for P1 process it is 13, and for P2 process this is 5. Let us find out the turnaround time, which is the difference of the completion time with the arrival time. So the turnaround time for P1 process will be 13 minus 0, 5 minus 1, 4, 22 minus 2, 20 is the turnaround time for P3 process. And now let us find out the waiting time. Waiting time will be how much time it is wasted. The processes, it means turnaround time minus the burst time. So 13 minus 9, 4 is the waiting time for P1. 4 minus 4, 0 is the waiting time for P2 process. P2 process was given the CPU the moment it has arrived. And for P3 process it will be 20 minus 9, that is the 11. Similarly, the response time, what is the time at which the processes have got the CPU? First time P1 got at 0 time, P2 got at 1 time, and P3 got at 13 time. ये relative time है with respect to 0, इसलिए हम इसमें से arrival time को subtract कर देते हैं. So arrival time for process number 1 is 0, process number 2 is 1 and process number 3 is 2. So, the response time is very good in the case of the Srtf algorithm if we are looking at the shorter jobs. Let us solve another problem related to the Srtf scheduling. In the Srtf scheduling, this problem is this problem looks to be very simple, and we have to preempt the processes after some time to look at the other processes which are arriving. Any of these processes or any of these numerical that you are solving have been asked in GATE examinations some time or the later. So, let us solve this problem also. In this problem, we have the process P1, P2, P3 and P4. Their arrival times are 0, 15, 30 and 45, and their burst times are given as 20, 25, 10 and 15. So, in the Gantt chart, at 0 time only one process is available, that is P1. So, let us allocate the CPU to the process number P1. The next process will be arriving at 15 time. So, P1 can freely run up to 15. So, the next check that can be applied is at 15 time. Up to 15 time or after executing up to 15 time, its remaining burst time will be 5. So, only process that is available at the 15 time is P2. P2 has a burst time 25, so it cannot run. So, we will have to continue P1 process for 5 more time. It means up to 20 it can run, and at 20 time P1 process will finish. Up to 20 time only P2 is available, because P3 will arrive at 30 time. So, we have sufficient time. Let us pick P2 and run this P2 for some amount of time, means up to the arrival time of P3. So, 20 से 30 तक हम रन कराते हैं P2 प्रोसेस को, और 10 यूनिट ऑफ टाइम तक ये रन करेगा, इसका रिमेनिंग बर्स्ट टाइम 15 होगा. At 30 time P3 is also available. So, let us compare the burst times of P2 and P3. P3 is a smaller one, so we will allocate the CPU to P3 process. Let us allocate this P3 process for at least up to its completion or up to 45 time. So, since it has only burst time 10, so it can run up to 40 time only and will finish. So, the remaining burst time for the P3 process will be 0. So, again at 40 time I have only one process, that is P2. So, let us allocate the CPU back to the P2 process. So, if we allocate this to up to 45, because at 45 the new process P4 is arriving, it will have the remaining burst time as 10. So, at 45 time जब P4 भी आ गया है, तो we have two processes with the burst time 10 and 15. Obviously 10 वाला select किया जाएगा, और P2 will continue its execution till the completion. After this we have only one process, that is P4. So, P4 will be picked up for the allocation and it will run up to completion. So, 55 से 70 तक ये जो P4 process है वो run करेगा. Now, let us find out the parameters. The completion time, let us look at the Gantt chart from right to left and see what is the last time the process has appeared in the Gantt chart. So, process number P4 is seen at 70 time, process number P2 is seen at 55 time, process number 2 is seen, process number 3 is seen at 40 time, process number 1 is seen at 20 time. Let us calculate the parameter for the turnaround time, that will be the difference of the completion time with the arrival time. So, the turnaround time for P1 process will be 20 minus 0, 20. For P2 it will be 55 minus 15, that is 40. For P3 it will be 40 minus 30, that is 10. For P4 it will be 70 minus 45, it means 25. Fine. So, we have calculated the turnaround time. It is the turn for the waiting time now. Waiting time is turnaround time minus the burst time. So, this will be 20 minus 20. We are actually calculating the time which has got wasted for a process. It has not done nothing, it was waiting or it was doing the IO operation. It has not executed the CPU for that amount of time. So, turnaround time minus the burst time, 20 minus 20 is 0 for P1, 40 minus 25, that is 15 for P2, 10 minus 10, 0 for P3 process. It means P3 process has not waited for any time. It has come to the ready queue and it has got completed. Then 25 minus 15, 10 for the P4 process. Now, let us calculate the response time. Response time is calculated by looking at the Gantt chart from left to right. So, the P1 was given the CPU for first time at 0 time, P2 was given at 20 time, P3 was given at 30 time and P4 was given at 55 time. Now, this is the relative time. So, let us subtract the arrival times from this. So, 0 minus 0, the response time for P1, 20 minus 15, 5 is the response time for P2, and then 30 minus 30, 0 is the response time for process number P3, and 55 minus 45, 10 is the response time for process number P4. Similarly, we can compute the average waiting time, average turnaround time and average response time. So, the average response time will be 10 plus 15, 15 by 3 means 5. You have to sum all the response times and divide it with the total number of the processes. Average turnaround time will be, sum all these. So, this will be 95 divided by 3. Average waiting time, sum all the waiting times, that is 25 and divided with the number of the processes. So, this is the Srtf scheduling algorithm in which we are calculating the parameters according to the number of the process or the process which is having the least burst time at any given point of time. So, we have several numericals, you can note it down to solve. For example, in this you can see that a very big process has come in the beginning, P1 process with the 12 unit of burst time. Other processes which are arriving at 2 time, 3 time and 8 time are the smaller ones. So, we will be preempting the P1 process and we will be giving the CPU to the other processes. It will so happen that P1 process will be given the CPU for 2 unit of time, then it will be preempted back, and next time when we will be giving the CPU to the P1 process will be after the execution of P2, P3 and P4. You can have a verification that P2 has a burst time of 4, P3 has 6, P4 has 5, all these are less than P1. Even after the execution of 2 times, the remaining burst time for the P1 process will be 10, which is higher than or larger than the burst times of process number P2, P3 and P4. See this question. In this question again, the P1 is having or the P1 process is having the highest burst time. The other processes P2, P3 and P4 are having less burst time. So, one time you will be allocating the CPU to the P1 process because it is the only process available at 0 time, but after that the process number P2, P3 and P4 will be getting the priority because of their shorter burst times and they will execute, and P1 will be allocated the CPU after the completion of P2, P3 and P4. So, here we are seeing that if a larger process has come in the beginning, it will have to wait for a long time. It means there is a starvation for larger processes. If the short processes will keep coming in the system, then the large processes may have to wait indefinitely. So, this condition can be said as the starvation for the bigger or the larger processes. Obviously, there will be lower response time. It means the process which are coming and they are short, they will be giving the CPU first. So, here if you calculate or if you compute, the lower response time will be there. And moreover, since larger processes, if the shorter processes are executed first, in the unit time the number of processes which will be completing will be large. It means the turn or the throughput for the system wherein we are running the Srtf algorithm will be high. Thank you. This is the reference. Thank you.